Good evening and welcome to the House of M. This is Physical and Earth Science. We're going to do a lecture today on speed of a wave. I am Mr. Marno. I'm sure you know me. Running the camera is Miss Mangiarelli. You know her. This is very low key. Basically did a lecture that we typically do on the board on paper. But this is just so you can get the worksheet that we assigned later in your assignments today. So you know how to do them. So here we go. We're going to look at...
This is like the evening edition.
I know, it's crazy.
Just so you, FYI, little freshmen, it is Thursday night at that time.
Yeah,
And we're still working for you.
that's right.
Just saying.
So when we looked at speed before, things that move have speed, right? So they go a distance and they go, the distance that they go takes a certain amount of time, and we would define that as speed or distance over time. So let's take a look at speed of a wave. You might want to go straight side up because it does come out upside down. All right, super. So
I just can't get too close.
well, that's okay. That's fine.
Okay.
They can zoom in. So we're looking at the speed of a wave. So remember that waves are in motion. This is the science that we're dealing with right now is that everything is in motion. So waves are in motion. They can move left to right. So you can have a water wave coming in from deep in the ocean going to the shore. They can move up and down. So you can have a slinky moving up and down that can act like a wave. Or you can have something moving side to side. But either way you look at it, it's motion. So because they are in motion, they have speed. Speed is measured in meters per second. So hopefully you remember that from earlier in the semester that we measure speed in meters per second. But it's not as easy to calculate wave speed as d over t. Because waves are just not as easy as a car or your students moving down the hallway and timing them and calculating their speed. So how do we measure that? How do we measure the speed of a wave if it's not quite as easy as, a car going down the road or a person walking down the hallway? So let's take a look at a wave again. So whenever I say wave at this point, what I'd like you to imagine is a water wave, because everybody's gone to the beach and everybody has seen a water wave. So you have a water wave that's coming in out from the ocean and coming into the shore. So don't worry about the crashing part. Just imagine you have this undulating up and down wave, right? We've seen this diagram before the other day. So here we have just a regular wave. I've done my best to make this symmetric. It didn't work out so well, but we don't really care about these points. I did my best, but it was already Sharpie, so too bad. So generally speaking, what we're worried about right now is the wavelength of a wave. So if you remember that from last time, the wavelength was the distance from the crest to the crest. So here I've defined it again. Here's the crest of this wave. Well, here's the crest of the wave here, and here's the next crest here. The distance from here to here is called the wavelength, and here we have length. Now we give this quantity a very special name. We call it that, which is pronounced lambda. Lambda, in case it looks like a giraffe landing on its side. Some people have told me it looks like a drunken person walking down the street. It doesn't matter what you want to call it. It's a Greek letter, and the Greek letter lambda. I guess we ran out of regular letters, but that's how science goes. So we use a lot of weird letters. So this is a lambda, and it represents wavelength. Come over here. So lambda is wavelength. Length. So length is measured in meters. So it's just because it's a wavelength doesn't mean you are going to measure it in different types of length. We're just going to go ahead and measure it in meters. But it's not the same as, again, taking a meter stick and measuring the width of the door or the length of the hallway, because now we have to deal with the length from crest to crest or trough to trough. So now we have a new quantity called wavelength. It's called lambda. Get used to writing that. But we need another quantity in order to calculate the speed of a wave, and that quantity is going to be called frequency. Again, let's get back to lambda for a second. If we're looking at the speed of a wave that's, let's say, like a water wave going out from the ocean into the shore. I know I'm going to get it. I'm not going to go yet. Think about it. If we're looking at speed, distance plays into the speed of an object. How far did the wave go? How far did it go in distance if I'm trying to figure out how fast it's doing it, right? So we need to figure out, that's why we're bringing up this notion of wavelength, but now we're going to bring up the idea of frequency. All right, here we go, and there's that one.
It's like magic.
I know. So what is frequency? Well, let's look at the word frequency. Frequency has the word frequent in it. So how frequent does something happen. So you've seen the word frequent before. Anything that happens regularly, you could say is frequent. So how frequently do you have meals at home? 3 times a day? That's a frequency. How frequent do you have meals at home? 2 times a day. And guess what? That's still a frequency. How frequent do you go to the bathroom in a day? Well, depends how you're feeling. Sometimes 1, sometimes 15. But that's all that many times per day. How many times does your heart beat per minute? That's a frequency. How many times do you breathe per minute? That's a frequency. So all of these things are frequencies. So right now we're looking at the frequency of a wave. So in this case, for waves, it answers the question, how many waves pass by every 1 second? How frequently do waves pass by in 1 second? So if you're at the ocean and you're seeing the waves go by, you can count them. You can go, oh, there goes 1, there goes 2, there goes 3 waves, there goes 4 waves. And if you say that took 10 seconds, and you could say there was that many waves happened in this amount of time. How frequently did the waves come by? Or if you're on a boat and you get seasick, you're really worried about how frequently you're going up and down on the wave because you have seasickness and you want it to stop soon. That's why I don't go on boats for other reasons. Anyway, so let's get an example here. I watch 5 water waves pass by. By my stopwatch, that took 1 second. So I'm at the seashore, I see 5 waves go by. I look at my stopwatch and I timed it took 1 second. So 5 waves in 1 second equals the frequency of that wave. I counted 5 waves per second. So that's for how frequently did the wave come by. Let's do another example. I watched 5 waves pass by. By my stopwatch, that took 6 seconds. Now wait a minute. It's the same number of waves, but it took longer. So do you think that's a quicker wave or a slower wave? By my estimate, that would be a slower wave. Same number of waves, but it took longer. So they're probably coming by slower. So here we have that relationship to speed again. So 5 waves in 6 seconds, if you do that in your calculator, is 0.83 waves per second. So you don't even get a whole wave in 1 second. So again, you want to come back up to here. How many waves pass by every 1 second? So even though we had 5 waves in 6 seconds, if you divide these numbers, you get 0.83 waves per 1 second. We're always trying to get back and down to 1 second. So let's talk units. What do we measure frequency in? So I'm going to take this last example. 0.83 waves per second. Really? That's just like 0.83 seconds, because you know what? We don't care what we're measuring the frequency of. Maybe that's 0.83 bathroom breaks per second. Maybe that's 0.83 breaks per second. We don't care. So we're just going to ignore the fact that it says waves. We're just going to say 0.83 seconds. 0.83 per second. Per second gets abbreviated as hertz, named after a scientist. Named after a scientist, Heinrich Hertz. And then we abbreviate that as Hz. So let's get back to the most important. If this is confusing, don't sweat it. 0.83 waves per second gets abbreviated hertz, Hz. That's all you need to know. These steps in the middle are just to kind of clarify. But if you see that, it means that.
Well, and hertz is cycles per second or waves per second. Yeah. Mm-hmm. So that's how many waves per second went by, not even a whole wave or cycle per second.
Right, it's just that many. So it's not even a whole one. So frequency F is measured in hertz. Maybe you listen to a radio station. If you listen to a radio station, and let's say you listen to 94.1 FM, 94.1 FM, 94.1 is 94.1 megahertz. And that is the frequency that radio station carries. 94 million hertz of waves. I didn't say that right, but you get what I'm saying. If you listen to another station, say 106.3, that's their frequency. Their radio frequency is 106 million hertz.
So that's how many of their waves reach you per second?
Per second, yep. So that's how many, that radio signal is oscillating that many times per second. So I'm just bringing up where you may have heard hertz before. Right now we're just worried about water waves. 3rd page. Here we go. Let's put it all together. Now we got math. Dun, dun, dun. Math. So now we're going to calculate the speed of a wave. New formula. Here it is. V, speed, is equal to F, frequency, times wavelength, lambda. So once again, we have V is speed, F is frequency, wavelength is lambda. Speed is measured in meters per second, frequency is measured in hertz, wavelength is measured in meters. So now we have a couple of examples done out. Example, a wave has a wavelength of 1.2 meters and a frequency of 6 hertz. What's its speed? So we're going to go right into the formula. V is equal to F lambda. F is 6 because it says hertz. Lambda is meters, so that's the 1.2 meters. So 6 times 1.2 is 7.2 meters per second. Now down here I've done a bit of a breakdown on where this comes from, but all you really need to know is if it's speed, it's meters per second. It doesn't matter that this doesn't look like d over t. F times lambda is meters per second. So as long as that's something you can study, that speed is measured in meters per second. So as long as you get these numbers right, it's 7.2 meters per second. And always, always report the units. It will not accept 7.2 with nothing on the end of it.
Or 6 times 1.2.
Yeah.
It needs to have the
Yeah,
units.
you got to put those in there as well. Example, the speed of a wave is 330 meters per second. That's fast. That happens to be the speed of a sound wave. If its frequency is 440 hertz, what is lambda? I'm looking for the wavelength. So I started with my original formula. I did some algebra. I need to get lambda by itself. So I divided both sides by f, crossed out an f here. What I'm left with is lambda equals v over f. That's going to be equal to 330 divided by 440 meters per second and hertz. Put that in your calculator, you get 0.75 meters. It's wavelength. The units are meters all the time, as long as we'll usually give that to you in the right unit. So wavelength is meters. Example, the speed of a wave is 1,498 meters per second. That's fast. That's the speed of sound in water. That's the speed of sound in air. They're different. But anyway, the speed of a wave is 1,498 meters per second. If its lambda is 0.20 meters, what is its frequency? Again, we start with the formula. V is equal to F lambda. We need to get F by itself. We're going to divide both sides by lambda. Lambdas cancel out. I'm left with F is equal to V over lambda. So I get 1498 divided by 0.20. Put that in your calculator and you get 7,490 hertz. So that wave, there were 7,490 waves per second for that particular wave. And obviously that must be going fairly quickly. If you get that many waves, almost 7,500 waves in 1 second, that's got to be a fast wave. Or it's a very compact wave. So that is my kitchen version, quarantine version of calculating the speed of sound. Believe it or not, you have all the information that you need to do worksheet 20.1, which is on class work for today. Please email me with any questions, but you really want to focus on the worksheet. You want to focus on the formulas and do the best you can. So that is all I have for now. This is Mr. Martineau. Don't call me Chris. Mr. Martineau signing off. Miss Mangiarelli signing off, and we'll see you next time. Thanks.